طيب بسم الله الرحمن الرحيم. So we'll start chapter 9, IP security. So the question that we should ask ourselves, we talked about securing a service through Kerberos, through certificates, right? We talked about securing a physical port for the case of network access. We talked about securing logical port in the case of wireless, right? Why do we need IP security?
Because the connection is not secure.
The connection?
Not secure.
The connection is not secure. Which connection?
Between, not from point to point.
The infrastructure. The network infrastructure is not secure. The network infrastructure is not secure. So, as we have studied in Network 1, we have the application data, right? And then we have a bunch of headers. So we talked about the application header, right? Which is, let's say, like HTTP or something. This is the application header, HTTP. And then we talked about the transport header, like TCP مثلا, صح? And then we talked about network header, low IP. And then we talked about data link layer header or network access header, like مثلا Ethernet header, صح? So when we talk about in the chapter that we discussed Kerberos and we discussed certificates, which part of this do we actually secure? So what we really secure is this part. So actually what we do is that we secure the data part in the application layer, right? So when you talk about securing service, let's say like email or something. So what you really work on in terms of security is this part. So this part needs to be encrypted and you need to add the MAC, right? The message authentication code for authentication. And in fact, we talked about tickets. In the case of Kerberos, we talked about tickets for authentication, right? But the application level header is not to be encrypted, right? So this will allow you to secure one single application, right? But all the other lower layers are not touched. So this can give you some level of security for securing one single application. But what about all the other applications that run on this host? And actually, when we talk about application, we talk about one application here and one application there. So we can actually talk about securing the entire application, one application to one application, which is what we will talk about later for TLS. TLS, because transport layer is used for what? Application to application communication, صح? We have sockets end to end. But this is application to application. ماشي كده؟ For application to application communication, we can use TLS or SSL or something like this. ماشي? And we'll talk about this in the next chapter. But again, this secures application to application communication, right? Which involves actually everything in the middle, طبعا يعني. But the problem is that if you have a host, first this host runs on a private network, right? And this private network has some internet service provisioning through a core network, right? And then you have another remote network which has many hosts, many other hosts. And of course here we have مثلا a router مثلا ولا حاجة زي كده, or multiple routers.
By private network, you mean the LAN?
By private network, I mean a LAN, and this LAN has internet connection مثلا through Ooredoo, through بقى routers and so on, right? So application to application security, in fact, is not in this picture. It talks about the fact that you have inside this host, you have some apps, some application endpoints. صح? And here you have some apps, and here you have some apps. So that one single host has hundreds of apps, صح? So when we talk about application to application security, we talk about this communication, right? So this communication from a transport layer perspective, which means that this whole part is secure, but not the TCP header. TCP header itself is not to be encrypted, because if it's encrypted, the transport layer cannot really process the header. Okay? So when you talk about application security, then the application data is encrypted, but the header is not encrypted. When we talk about transport layer security, the application header and the data are encrypted, but not the TCP header, and so on. The lowest level we talked about for port security, for physical, for network access security, we talked about securing this whole thing, right? But again, this part is not to be encrypted. Otherwise, the switch cannot really process this data, right? So in any layer, if you want to implement security, you actually encrypt the data part of the PDU, but the header is not encrypted. Okay? طيب هتقول لي احنا okay, so we talked about network access security, which means all of this is secure and encrypted and everything. Why بقى do we need IPsec? Why do we need TLS? Because of this, remember, if you have application to application security, you have tons of other applications that run on this host. So just the fact that this application is secure through communication with another app, that doesn't mean that all these applications, they have the same level of security or the same or security altogether. Okay? يعني here this application uses SSL. What about the user who types HTTP only without SSL? So this means that this application might not have security, which means that this application uses no encryption and no authentication. Okay? طيب, the problem is that if this application is not secure, this application itself can be compromised, in which case it can inject, as we said, it can inject some messages into the infrastructure that can really perform بقى in network injection ولا حاجة زي كده، صح؟ طيب هتقول لي طب خلاص، طب ما احنا we secured the entire frame. All the frame is which means that it's a very low level. صح، بس network access layer is used for what type of communication? Device to device communication. صح؟ Device to device, huh? Not end to end. So network layer security, network access layer security talks about the fact that you secure from here to the first entry point only. صح? So this port physically uses encryption. Okay, so all of this is encrypted and authenticated. صح. But once you reach the first entry point of any device in the network infrastructure, خلاص, everything goes back to normal, and the frame gets decrypted, and it goes to the infrastructure plane. صح? Again, network access security does not provide end-to-end security. So neither application guarantees full security for the network infrastructure, nor the network access layer security provides security for the network infrastructure. Okay? طيب. That's why we need another level of security. So when we talk about security from the routing layer point of view, what does that mean? This means network security as a plain definition provides what type of communication? Host to host or network to network. صح؟ مش احنا كنا بنقول كده في النتورك 1؟ Okay? So host to host means that خد بالك بقى not app to app, huh? Not application to application now. Here we're talking about host to a host. Here. So you build like some kind of a tunnel, okay, between host to host. This means what? This means that any application runs on this host will by default use that tunnel. Okay? So this is about the advantage of security from the network layer. واضح كده؟ So when you do the security from the network layer, all the apps on this host by default, okay, they have to go through this tunnel. I will talk about some exceptions. But by definition, all the apps on this host will have to go through this tunnel, which means that the whole host is secure. All the host is secure. ماشي? Which means that this host is guaranteed not to damage the network infrastructure. ماشي كده؟ دي الميزة. لأن لما بتكلم على transport layer security, I can secure an app. But what about all the other apps? They are not by default secure. Somebody uses UDP ولا somebody uses HTTP without S. ففي الحالة دي مش مستخدم transport layer security. This app is not secure. And this app can be used to damage the network infrastructure. واضح كده؟ Network access layer security also does not guarantee securing the network infrastructure. Why? Because it's device to device by default. ماشي؟ But that's why we need بقى ايه؟ A platform that really can guarantee the security for the network infrastructure end to end. Not app to app, لا. So IP security بقى provides this, and we'll see that IP security is the most complicated one. Why? Because it secures host to host or network to network. By network to network, we mean the same tunnel can be, in fact, implemented not at the level of the host, لا. From one router here to one router here. Okay? What is the implication of this? Any application running on any host in this network will have to go through this tunnel. Okay? So we can do IP security host to host or network to network. ماشي? Or in some cases host to network. we can do this. ماشي؟ مفهوم كده؟ واضح؟ So this is to answer the question is that why do we need to have security from each layer? Now we need background from network 1 in order to answer this question. Security at certain layer does not really guarantee the security of the network infrastructure. طيب, and also when we secure at a certain layer, what is the implication of this? We actually encrypt and authenticate the data part. But the header has to be, it's a rule كده, the header has to be exposed. I have to do this because otherwise I cannot process the header. I cannot process a header that's encrypted. Okay? هتقول لي ما أنا عندي الكي بس أيوة ما هو this before I encrypt ولا decrypt I need to process to see أصلا whether the data part is valid ولا it has errors ولا okay? And actually if you send مثلا تخيل أنت you send an IP packet, okay? IP packet secures end to end, right? And the header is encrypted, and you send this to a router. So how can the router perform routing أصلاً if the header هتقول لي ما الراوتر has keys؟ لا, الكيز موجودين end to end. صح؟ So the router needs يعني to read the header in order to perform routing. Okay? But these are rules, these are facts that we need to understand in our mind. This is a private LAN, right? And this is a private LAN, and they are interconnected using a WAN. Tamam? So we can provide security for between this private LAN and this private LAN, in which case we establish a tunnel. We call it actually a tunneled mode. We call it كده, a tunneled mode for IPsec. IPsec has two modes, we'll talk about them. So we establish a tunnel between one network and another through a router or firewall. يعني the firewall can be replaced by this router. يعني. So the firewall can يعني act as a router. ماشي كده? So we can provide private LAN to private LAN security, which means that any application running on any host in this private LAN will be secure. ماشي؟ So يعني مثلا that's why يعني I'm not sure if you've noticed, if you try to call anyone using WhatsApp from your house, you have some problems, صح؟ مش عارف انتوا you tried this or not. When you connect on VPN, you see the voice quality is perfect, صح? Why? Because radio blocks certain traffic, and they can see that because it's if you are not using any VPN, خلاص, everything is exposed, and they can detect the service, so they can block it, right? Or they can throttle it. They call it throttle it. ماشي? If you use VPN, they don't see what traffic is inside the pipe. They don't see anything, so they cannot block it. So that's why you see the voice quality is very good, because they are not throttling anymore. Try to do the same thing from inside the university. You don't need VPN. Why? Because the university actually uses VPN to connect to outside by default. So any application running inside QU by default uses IPsec to get outside. واضحة دي؟ ماشي؟ So that's why you don't need.
So Rido can't see the traffic of the university.
Well, to some extent, at least for certain types of traffic. And we will see that we have, in IPsec, we have the concept of اللي هي policies, security policies. Okay? Security policies based on some agreement. So there are certain types of traffic that they need to see. In that case, this traffic bypasses VPN. It doesn't go through VPN. Okay? But by default, the traffic goes through the tunnel, you don't see it. ماشي كده؟ Let's imagine here that this is مثلا an office of Microsoft. So this is Microsoft Office 1, and this is Microsoft Office 2. Okay? So these are two offices of Microsoft which are geographically distant, one in Europe مثلا, and one in the US. Okay? So Microsoft, they need to have security to communicate between these offices. اللي احنا سميناها ايه؟ فاكرين؟ intranet. فاكرين؟ فاكرين سميناها intranet. صح؟
Outside the company.
Yes. Same company, okay, but it's a private traffic. Nobody should see it. ماشي؟ طيب, so one option for Microsoft is to say, okay, so I'm going to actually build a network infrastructure between the two offices, which means that I'm going to dig some network infrastructure through these offices to make sure that nobody looks at it. Of course, this is highly costly. The other option is to use the internet. And you get some agreement with a service provider, we'll go through the internet, but the internet by default is public.
So we need a private channel.
So we need بقى في الحالة دي to build a private tunnel inside a public WAN. Okay? IPsec بقى helps you to do this. IPsec builds a logical tunnel over a public WAN, okay? Despite the fact that the internet infrastructure is by default public, but no one can see that tunnel. No one can see what's inside that tunnel. Okay? Routers can see the header to perform routing, but they don't know what's inside. and they cannot know what's inside. So this is what we refer to as a logical tunnel. ماشي? So IPsec can provide private LAN to private LAN security through public WAN. This is one of the most famous scenarios for IPsec. ماشي? And as we said, we can have different combinations. We can have host to host, so we don't have to secure office. We can provide IPsec on the level of a host. Okay? So, for example, we can use that مثلا for a scenario where we talked about remember we talked about the scenario where Muhammad took his laptop and he's traveling abroad in a hotel, and the hotel does not have any security in the wireless LAN. ماشي؟ طيب, how can I make my traffic secure? I can connect using VPN to QU. Okay? So this way, I can use any infrastructure inside QU using that tunnel. ماشي? So now, any application that Muhammad runs on his laptop will by default use that tunnel and will be secure to reach the infrastructure of QU. And QU, they have the security policy that says, if your traffic is coming through this VPN tunnel, I will allow it to access any server inside QU. That's why if you want to access a server inside QU from outside, you have to use a VPN. So you can connect a host with a network through a tunnel. You can connect a network to a network, or you can connect a host to a host. Okay? In IP security, you have very high flexibility. So now we agree, we are motivated that خلاص, we need IPsec. We need security in the routing layer. We talked about network access layer, but it's not enough. We need routing layer to perform end-to-end, host-to-host or network-to-network. So IP security, okay, IP security is a standard, right? IPsec is a standard. And it's the predominant standard in the network layer. This is the most famous one. This is what we use when we trigger any VPN. So VPN uses IPsec. ماشي? So when we use VPN, by default, we use IPsec. And that's why in VPN, we just make one connection VPN, and all the applications, خلاص, all the application will go through that tunnel. But we'll talk about some exceptions now. طيب. So IPsec is detailed in a standard, ماشي, اللي هي RFC 1636. But actually, IP security standards is actually detailed in like 10 different documents. This RFC provides only the overview of the standard. This RFC only explains the architecture. But in this architecture, we have multiple components, and each component is detailed in another document. فعشان كده ال IPsec as a standard is actually it's an umbrella of specifications. واحد زي ما هنشوف for ESP, واحد for AH, one for key management and distribution اللي هو IKE. Okay? And different documents that we will talk about. So this RFC only provides overview specification for the architecture. ماشي? Other than this, هنلاقي bunch of other documents. Also, there is IPsec for version 4 and IPsec for version 6. ماشي? IPsec for version 6 is a lot more complicated. And we will not cover all of it in this chapter because it's very, very, very detailed. And actually, even the background that we talked about in Network 1 will not allow us to go through many of the details. ماشي? Because in Network 1, we did not cover IP security with enough details. ماشي? That's why this regard, and that's why the standard is very, very complicated. So that's the overview. IPsec provides capability to secure communication, communication across a LAN, private and public WANs. So, as we said here, it provides secure communication across a LAN, private LAN, and public WANs. ماشي؟ what happens is that طبعا انت if you have let's go VOC ماشي كده؟ So this is the this shows you the scenarios that we just talked about. So here we talk about, of course, IP payload, اللي هو payload اللي هو data part, and then we have the header part, right? So this is the normal IP. So now I need to provide some IP level security. Okay? So here what I could do is to say, okay, so I'm going to encrypt the IP payload, right? And leave the IP header exposed. ماشي? So this is what we talked about. And if you notice, here the authentication part, authentication معناها إيه? Authentication معناها we have to create a signature for the data, right? And then encrypt the signature using one of the encryption techniques, اللي هو الماك. Okay? So the signature can be calculated based on the header. So the header can be included in the signature, but it's not included in the encryption because it has to be exposed. Otherwise, the router cannot perform routing. واضح كده؟ طيب. IPsec بقى, to make it more complicated, they define two different modes of operation. One is called the transport mode. In the transport mode, only the IP payload will be encrypted, right? And this header will be left exposed. And we'll talk about this scenario. Here we have what we call the tunnel mode. In the tunnel mode بقى, we do something very interesting. We actually encrypt the payload and the header. In the tunnel mode بقى, we talk about a tunnel between this firewall and this firewall, or this router and this router, which means that you have to provide security from one complete LAN to another LAN through a public WAN. This is the more common scenario. We call this a tunnel mode. Okay? So in fact, when a host here tries to communicate with another host here, once it goes here, we do this operation by constructing that tunnel. And the way we do this is to say we'll have to encrypt the IP payload. We'll have to provide authentication, right? And then we send it over the tunnel. However, here, by the way, part of this tunnel is that this IP address is which IP address? The IP address of the final host. صح? Because this host wants to communicate with this host. So the IP here is the IP of that host. صح? When it goes to this tunnel, when it goes to the entry point of this tunnel, what is the IP address that should be in the header? The output of that firewall. Right? Not the final host. Okay? So that's why in the tunnel mode, they do something very interesting. You need to stay focused here. They actually encrypt the payload and the original IP header all together. I don't want to know where this packet is coming from, which host in the LAN. I don't care. I don't want to see this. So what they do is that they encrypt the whole thing, the IP header and the payload, and then they add the security header, which we will talk about, and then they add what we call an outer IP header. This outer IP header will be used to route through the internet, the public WAN, over the tunnel. And the IP here is the IP of that firewall. Once it reaches here, خلاص, everything will be removed and the original IP will be. So here, the traffic inside this private LAN is not secure. Because by default, it's a private LAN. It's a private LAN. يعني inside the university here, it's a private LAN. خلاص, we don't have to implement. We can implement بقى network access security. We can secure بقى physical ports and so on. That's fine, but we don't have to provide IP level security. IP level security is only needs to be provided when we communicate outside. ماشي كده؟ طيب. So we have here two modes that we will talk about them in details later on. So the common scenarios are either private network to private network security over a public WAN, or a host to host security or a host to network. So I can provide a tunnel. In that case, we call it a transport mode, not a tunnel mode. We call it a transport mode, and we'll talk about the difference between the two. Now, we'll talk about it in details. Okay? But this is from a high level, the scenarios that we talk about. Because again, this goes back to the original definition of network layer. Network layer provides host to host or network to network communication. So again, IPsec provides host to host security or network to network security or host to network security. ماشي كده؟ طيب, so the benefits of IPsec. So when IPsec is implemented in a firewall or a router, it provides strong security that can be applied to all traffic crossing this perimeter. So when I implement IPsec inside a router, this means by default, everybody in this private network will go through that tunnel, which means all the applications that are going to be secure by default. Okay? And remember, Bardo, there is a fact that IPsec is very heavy. IPsec itself is heavy. Okay? So sometimes it's more preferable to run it on a router or a firewall to have everybody secure in the LAN. Okay? So that's why if you run مثلا VPN on your laptop abroad, you see طبعا in cases like WhatsApp وكده, you see the voice quality is good, but actually the traffic is slowed down. Okay? The traffic overall is slowed down. Why? Because IPsec is heavy, it's complex. And we will see how complex it is. It's very, very complex. So unless you are actually forced to do that, you should not run VPN on your laptop unless you have to. So by default, you run it on routers or firewalls and have everybody inside the private LAN secure. ماشي? But IP in a firewall is resistant to bypass if the traffic from the outside must use IP, and firewall is only means of entrance from the internet into the organization. So this is the scenario that we talked about. If you are abroad and you want to connect to your organizational network from outside, so we just need a tunnel between your laptop and the organizational network that you are part of. Once you hit the firewall, okay, now the traffic goes inside and it goes through inside the organizational network. Actually, not secure, not encrypted in that case. ماشي? IPsec طبعا is below the transport layer, which means that both the TCP header and the data and the application header, all of this is encrypted, of course. So the question is, should the IP header be encrypted as well or not? That depends on the mode. We have the transport mode and we have the tunnel mode. In the tunnel mode, even the IP header is encrypted, as we will see. IPsec can be transparent to end users. Hence, there is no need to train users on security mechanisms. So, in fact, as we will see, there are some security policies that I can, for certain users or for certain IPs or for certain type of traffic, you can bypass the VPN. Which means that you have a tunnel, okay? But for certain type of traffic that comes from a certain host, this traffic will not go through the tunnel. It will go through the public internet normal. Okay? Type. Why do we need to do this? A logical security policy would be that مثلا if مثلا Nawaf is using HTTPS, which means that he's using مثلا TLS or SSL, صح? So his app is secure, okay? And SSL in that case provides application to application security. So when his traffic comes into the router will say, okay, so this traffic is coming and he uses TLS. So why duplicate the work? خلاص, the traffic is coming encrypted, صح? And there is no harm of this traffic on the network infrastructure because it uses already security, صح? So in that case, I don't have to duplicate the work. So I can bypass it and keep it away from the VPN tunnel. I don't have to route this traffic into the VPN tunnel. That's a very common example, مثلا. Okay, but I can use whatever policies I want. Certain types of traffic, they do not go through the VPN. As we said, مثلا أريد, they have certain agreement مثلا with the university. Certain type of traffic coming from QU, لا, I need to see what's inside. Certain types of traffic, لا, خلاص, okay, it can go through the tunnel. ماشي كده? So security policies can allow you to bypass the IPsec tunnel if needed. ماشي? And we'll talk about the details of this. طيب. ماشي. So IPsec can play a vital role in the routing architecture. As we said, that if there is any application that's not secure, this application can be used to inject some messages and corrupt or damage the network infrastructure. صح? So IPsec is specially designed to secure routing level messages, like any kind of مثلا route advertisement. فاكرين في حاجه اسمها route advertisement, route solicitation as part of IP version 6, route updates, ماشي. ICMP, remember ICMP برضو, we use it for ping and troubleshooting, and it generates some packets in the network layer. A redirect message that comes from the router to which the initial IP was kind of modified, like what? NAT, فاكرين NAT? Network address translation. صح? NAT itself is used, فاكرين, the main objective of NAT was to mitigate the IP exhaustion, اللي هو ال IP shortage. Okay? It's not security. NAT is not done for security, صح? But as part of NAT, the router needs to flip the IP before it forwards it to the internet. So this is another routing level messages that the router has to do. So again, this can be secure, and IPsec can be a good candidate to secure these types of messages. ماشي? So any messages in the routing layer can be secure, which guarantees again no injection to the network infrastructure that can damage the network infrastructure, routers or switches or something like this. ماشي كده؟ هو بس أنا مش عاجبني فكرة طيب